We'll start with an example of synchronous machine where the question is like three-phase star connected. Question is like a three-phase star connected 400 volt synchronous motor takes a load of 52.5 ampere at a power factor of 0.8 lead. We have to calculate the power supplied and induced EMF. That the motor impedance per phase is 0.25 plus J 3.2 ohms. So, in this question, we have to find the power first of all, then the EMF per phase. How to start with this question? In this question, we have to first of all find the power. And since it's a three-phase star connected 440 volts machine, synchronous motor, which is working at synchronous motor is working at 52.5 amperes and 0.8 lead power factor. So directly we can find the power, that is power supplied will be equals to Vi cos phi. Or since it's a three-phase motor, so under root of 3 will come. By putting the values, we can get under root of 3 into V is 440 into the current, that is 52.5 amperes, into the cos phi, which is 0.8, that is equals to 29.1 kilowatts. Now, this was the thing, but now we have to find the E per phase. So for that, first of all, we have to find the ZS. We have to calculate this thing ZS, and by the triangle of synchronous, we can know that this thing, that VP, EP is the angle, and this is suppose phi, this is theta, and this is the current I. So by this we can find induced EMF per phase, that is equals to under root of EP square plus of EP square or IZ square plus or minus of 2 into VP into IZ square, that is the voltage drop square, multiplied by the cos of 180 minus theta. Here, for that, first of all, I have to find the Z. The Z will be equals to the since this is right now in rectangular, I have to convert it into the magnitude form. That is, by solving the magnitude 3.21 ohms will come. That 0.25 square plus of 3.2 square under root full will be giving me Z is equals to 3.21 ohms. Therefore, I can find the impedance angle, that is the beta. Beta would be 3.2 divided by my 2.5. Tan inverse of 3.2 divided by 2.5, which will come approximately as tan inverse of 12.8, that is 85 point, tan inverse of 80, tan inverse of 12.8, which is equals to 85.93 degrees. So I got beta now. I can find the theta also. Theta is equals to tan inverse of my cos phi, that is theta 0.8, which is equals to 38.66 degrees. So the angle which we have shown, this was beta and this was theta, this was VP, this was EP. So beta plus theta would be 124.9. So beta plus theta would be equal to 124.9. Why I have beta plus theta? Because it's a leading component. What of this beta plus theta will come? If it is a lagging current, then it would be coming here somewhat. So I have to subtract that beta minus theta. So remember this thing, whether beta plus theta is to be done or beta minus theta is to be done. Whether if it is a lead, then beta plus theta will come. If it is a lag, beta minus theta will come. So here, since I got Z is equals to 3.21, I can find the IZ drop. That is I into ZS drop would come approximately as 52.5 is my current and Z is 3.21. So 52.5 multiplied by 3.21 would give me 168.5 volts. 168.5 volts. So I got beta, I got theta, beta plus theta I got as 124.9, IZ as 168.5. So by the formula, E per phase is equals to under root of Vp square plus I into Zs square minus of 2 into Vp multiplied by I into Zs into cos 180 minus beta plus theta. Everything is in the under root part. Vp square plus Iz square minus of 2 Vp into Iz into cos of 180 minus beta plus theta. From this I can get E per phase. So I can solve this thing. Everything will come in the root. Vp square I know, Vp is 440 plus I into Z drop I got at 168.5 minus of 2 multiplied by Vp is 440 again into Iz is 168.5 into cos of 180 minus 124.9. By solving this, I can get E as one thing which we have not we have not included. Extremely sorry for that. This is 440 volts for three phase. So I have to convert, since this is I am asking about the E per phase. So I have to convert this thing into V per phase first of all. This is the VL right now given, so I have to convert it into V per phase. So that will be 440 divided by 100/3, that is equals to 230 volts. So here this will not be 440, this will not be 440, this would be 230, here it would be 230. This is one of the biggest reason that even though some persons know the formula, some person know the technique of the question, but person normally get the wrong answer because of the reason that they are not converting these small things which will be actually giving the accurate answer. So this is called as a human error. So please try to remove these human errors. It will benefit you in the examination. So by solving this, I can get EP per phase is equals to 194.25 volts, and if I need to find the EL, I can have EL is equals to under root of 3 multiplied by 194.525, which will be giving me EL is equals to 336.45 volts. So in this question, only two things were very much important to understand. This was the universal formula which is normally being used in any synchronous motor E per phase question. So this is very important. Please remember this formula. Learn by heart this formula. Normally this is very normal questions can be solved by this formula. Another thing is that when it is leading, it is beta plus theta. When it is lagging, it is beta minus theta. Apart from that, nothing is more complicatory in this question. This is the answer, that is 336.4 volts.